Alright, this is a review of the homework I assigned on February 28th. It coincides with 1.1 in Decimal Labs. So let's get started. The first one, we have Drummond and his siblings ordered a pizza for $13.95 and 3 drinks for $2.25 each. After lunch, they bought ice cream cones for $2.75. What was the total cost of the lunch, drinks, and desserts? So to find the total cost, obviously I have to add all the costs up. So the first thing they ordered was the pizza, and the pizza was $13.95. Now, for the drinks, they ordered 3 drinks, and each drink cost $2.25. So what I have to do is do $2.25 times 3. And I know we haven't really discussed multiplication of decimals yet, but I know you've done it before. So 3 times 5 is 15. Let's carry 1. 2 times 3 is 6, plus 1 is 7, and 3 times 2 is 6. Now, if you think about it, there's really only one logical place I could put that decimal. I can't say that 3 drinks at $2.25 each cost me $675. I can't say it cost me $67.50. And it wouldn't make sense to say that it costs less than $1. So this is the only option I have right there. So I'm going to go ahead and put this in the line here, and as we've been talking about in class, I have to line up the decimals. And then, so that takes care of the drinks. For the ice cream cones, they bought 3 of them at $2.75 each. So again, $2.75 times 3. 3 times 5 is 15. We're carrying a 1. That's 21 plus 1 is 22. Carrying a 2. 2 times 3 is 6 plus 2 is 8. So again, just to do this technically, we can say that, well, there's no decimal places down here for the 3. For the $2.75, I have 1, 2 places. So what I do is I go down to my answer and just go over 1, 2 places, and that's where my decimal goes. So $8.25 for the 3 ice cream cones. Alright, and again, we're finding the total cost, so we're going to add these all together. Again, my decimals are lined up. Let's bring our decimal down so we don't forget it. Now it's just a matter of doing some addition. So 5 plus 5 plus 5 is 15. We're carrying a 1. That's 10 plus 7 is 17. Plus 2 is 19. We're carrying a 1. 3 and 1 is 4. Plus 6 is 10. Plus 8 is 18. Again, we're carrying a 1. And 1 and 1 is 2. So our total cost for their siblings, the total cost is $28.95. Moving on to the next one. So a rectangle has a length of 42.27 millimeters and a width of 19.425 millimeters. Area and perimeter. So the first thing, the perimeter, as you guys should remember, of a rectangle is 2 times the length plus 2 times the width. So if I go ahead and do this, essentially that's going to come out to 2 times the length of 42.27 millimeters plus 2 times the width of 19.425. So let's go ahead and do the math here. So if I do 42.27 times 2, 2 times 7 is 14. We're carrying a 1. 2 times 2 is 4. Plus 1 is 5. 2 times 2 is 4. And 2 times 4 is 8. So I have 2 decimal places. So I put 2 decimal places right there. So 2 times the length is 84.54. Alright, and then 2 times the width is going to be 19.425 times 2. And a good thing to do, guys, we've been talking about in class, is we can sort of estimate this, just to make sure our answer will make sense. So if I just say this 19.425, let's assume it's a 20. Alright, so 20 times 2 is 40, so my answer should be someplace around 40. So again, when it comes to placing the decimal, that helps us out a little bit. So we're looking for an answer close to 40. So 2 times 5 is 10, carrying a 1, that's 5 right there. 2 times 4 is 8, 2 times 9 is 18, carrying a 1. 1 times 2 is 2, plus 1 is 3. So the only place I can place this decimal, make logic sense, if it's going to be close to a 40, is right here. So I can go ahead and say that the 2 times the width is going to be 38 and 85 hundredths. Again, I don't need this trailing 0 there. So to get our answer, we're just going to add these two together. Again, let's keep our decimals in order. Alright, so this is a 3. So 9 and 4 is 5. No, 4 and 5 is 9. 8 and 5 is 13. Carrying a 1 and bring our decimal down. 8 and 4 is 12, plus that 1 is 3. Plus the 1 is 13, carrying a 1. 8 and 3 is 11, plus 1 is 12. So we have a perimeter of 123 and 39 hundredths of a millimeter. All right. So that's the perimeter. The area is just going to be, the area is going to be equal to length times width, or area is equal to 42.27 millimeters times 19 and 425 thousandths of a millimeter. So again, this is, I don't want to take too much time with the multiplication aspect, which we're going to cover in class. So for the most part, I would have been alright with you guys using a calculator for this. So if you go ahead and do this, you would have gotten 821 and 9,475 hundred thousandths of a millimeter squared. Alright? So again, here's our perimeter. And here is our area. Now soon, within the next few days, we're going to be doing all that with paper and pencil. No calculators. Alright, which group of decimals is ordered from least to greatest? A couple different ways we can handle this one, but so we'll look at them. So for F, I line up all the decimals here, and I see that all the first digits are 5, so that doesn't really help me out at all. So if I move on to the next digits, the numbers in the tens place, if these numbers should be in order from least to greatest if this is the right answer, but they're not. You can see I have a 6, a 9, a 0, a 9, a 1, not in the right order, so F isn't the answer. Another way I can look at this last number here has 3 digits after the decimal, so I can make all these numbers have 3 digits after the decimal just by adding a 0. I can add as many zeros as I want to any of these, and it doesn't actually change the value of the number. But instead of looking at now 6 tenths or 9 tenths or 9 hundredths, I'm looking at comparing 600, 900, 90, 960, 139. Obviously, they're not in order. For G, so far I have a 0 to start out with, a 10 at the end, and a bunch of 1s in the middle. So far, so good. So I'm not even concerned anymore with this number or this number. I just want to make sure that these 3 numbers are in order. Alright, so all the 1s are good. Let's look at the numbers in the tens place. And I notice that they are not in order. I have a 0, 3, 0, so G cannot be the answer. For H, again, the first digit in the 1s place is all 2, so it doesn't help me out at all. Move on to the next place, which is the tens place. And I can see that the numbers are not in order. 8, and then 1, 7, 1, 7 doesn't work. H isn't the answer. So, with all that being said, obviously J has to be the answer. So the first digit here in the 1s place are all 0s, doesn't help me out. If I look at the tens place, I can see that this first one is a 1, then a 2, so they're in order. And then I have 3 3s. So, I'm not concerned about this one anymore, or this one. I know they're in order. I just have to look at these 3. So the 3s don't help me out. So what I have to do is look at the number in the hundredths place. And this 8 definitely comes before both of these 9s. So this one is in order. So far 1, 2, and 3 in order. Now I'm just concerned with these 2 numbers. So the numbers in the hundredths place are the same. So go to the thousands place, and I have a 0 and a 2. 0 and 2 is definitely in order, so this checks out and is my answer. Again, I could have looked at this the same way I looked at the first one and said that this has 4 digits after the decimal, so let's make all of them have 4 digits after the decimal by adding some zeros. And now I'm just comparing 1,320, 2,300, 3,830, 3,905, 3,920. All of them are in order, so again, this is my answer. All right, moving on to number 4. So this was about the problem with dollars and cents here and hours and minutes. So obviously when I add dollars and cents, I could put those numbers into decimals and add them together. So it says since $3.35 plus $5.78 equals $9.13, the total is $9.13, right? So this works because up here, dollars and cents are based off the number 100. It's a power of 10. So the answer to this question down here, can you add 2 hours and 45 minutes to 3 hours and 57 minutes by using this problem right here? And the answer would be no, because hours and minutes are not based off a power of 10. If you look at this, 45 minutes, it does not actually mean 45 hundredths. It means it doesn't mean 45 out of 100, it means 45 out of 60, because there's 60 minutes, not 100 minutes. So 45 over 60 actually reduces to 3/4, which is equivalent to 75 hundredths. So if I wanted to go ahead and put 2 hours and 75 minutes into a whole number in a decimal, I'd have to write it as 2.75. All right, that represents 2 hours and 3/4 of an hour. Same thing over here. This 57 minutes does not represent 57 out of 100. It represents 57 out of 60, which as a decimal is 95 hundredths. So again, if I wanted to represent 3 hours and 57 minutes as a whole number in a decimal, I'd have to go ahead and say 3 hours, 3.95. Now if I add these together, this would have given me a 0, 9 and 7 is 16, plus the 1 from here is 17, carrying a 1, and that gives me 6. So the answer to this question right here is 6.7. So that means 6 7/10 of an hour. All right, now 6 7/10 of an hour. If I take 60 minutes and break it up into tenths, every tenth would be 6 minutes. Perfect. So every tenth would be 6 minutes because 60 divided by 10 is 6. So if I'm looking at 7/10, I have 1, 2, 3, 4, 5, 6, 7 tenths. 7 times 6 is 42. So 6 7/10 of an hour represents 6 hours and 42 minutes. Now if you went back to this problem right here and said 2 hours and 45 minutes plus 3 hours and 57 minutes, you'll actually get that represents 6 hours, 42 minutes, or 6.7 hours. If I did this problem right here, I would not get 6.7. Then I would get 6.02. All right, so moving on to the next one, last one, same type of problem here. The meters and centimeters are metric system. A metric system are based off powers of 10. So that's why that works. Can I add 3 feet 7 inches and 5 feet 6 inches by using decimal numbers 3.7 and 5.6? Again, the answer to this would be no, because our customary system of feet and inches is not based off 100. So you all know that there are 12 inches in a foot. So when I say here 7 inches, it's not 7/10 of a foot, it's 7/12 of a foot. And 7/12 of a foot as a decimal would be that. All right? And then 6 inches does not represent 6/10. It represents 6/12, because there's 12 inches in a foot. So if I'm getting 6 of those 12s, that equals 1/2 or 0.5. So if I wanted to represent 3 feet 7 inches in with a whole number and a decimal, I'd have to say 3.583, repeating. And if I wanted to represent 5 feet 6 inches as a whole number and a decimal, I'd have to write it as 5 feet and a half. So that's number 5.